All right, so here we are, we're going to graph quadratic functions. So a quadratic is a parabola, right? And so your basic equation for a parabola is f of x equals x squared. So whenever you see that format, if you see an x being squared, then that's going to be a parabola. Just like earlier when you saw absolute value bars, you're going to have a V shape in your graph, right? So it's like a style of a graph. It's like a parent function, you call it. So let's try mapping out a few numbers here. If you put -3 into here, so if I take -3, now remember I'm taking -3 and I'm squaring it. So that means -3 times -3, so I get 9. Then I get 4 and 1, 0, 1, 4, and 9. So what happens is no matter what, when it's positive or negative, it turns positive, right? And so when you graph those points, you end up getting here 0, 0, 1, 1, 2, 4. I can't really do 3, 9, but over here it's the same thing. So a parabola always has this pattern. It has its vertex and it goes out 1, up 1, right? Then it goes 2, 4, and then it goes 3, 9, and then I could go 4 and 16 and be way up here. But it does the same exact thing on the left-hand side, right? And so the slope, it doesn't really have like a linear slope like you're used to with absolute value, but it has that pattern to it. Now it has this pattern, the 1, 1, the 2, 4, the 3, 9. It keeps that pattern unless there is some kind of multiplier right here. Like if you take and you put a 3 there, well then these numbers are all going to be multiplied by 3. And so that would change your answer, but we'll talk about that later. All right, so your domain. So you can put anything you want into a parabola equation. You can see also that it goes right and left forever. These things, as they go up, they kind of like widen out, right? That's a little bit dramatic there, but they widen out. So your domain is -infinity to infinity. In this basic picture, my range is from 0 to infinity, and it's including 0. The max or min. The local max or min is also the absolute max or min, and that would be this vertex point right here. So 0, 0. And if your parabola is upside down, then that's turning into a maximum. To get your parabola upside down, you'd have a negative in front of it. All right, so oopsie. So also 0, 0. All right, x-intercepts right now is just 0, 0. But a lot of times a parabola will have 2 x-intercepts, because say my parabola would be down here. We'll see I'm crossing the x-axis in 2 places, or if it's upside down. Your parabola can do one of 3 things. It can touch the x-axis 1 time, so that's called a double root. It can pass through twice, and so you have 2 separate x-intercepts. Or your parabola might be positioned in such a way where, like, let's say it's down here, and then it's never going to cross the x-axis. So then it has no real solutions, no real x-intercepts. All right. Y-intercept is also 0, 0 for right now. And increasing interval. So remember, increasing is a positive slope. So that's this side right here. As you move from left to right, the y value is going up. So that happens from 0 to infinity. The decreasing interval is here. As I move from left to right, the y value keeps going down. Right? So that's -infinity to 0. And constant intervals, none. And behavior. Well, right now, parabolas always have the same thing on both ends. Like both ends are going up here. Or if it's upside down, both ends are going down. So for right now, it's both positive infinity. All right, so some transformations you can make. So your basic transformations, if you want to go left or right, you take your parabola, and inside with the x, with the square, you put a plus or a minus on your x. So let's say we had x plus, let's say 4. So remember, kind of like with the absolute value, you have to think to yourself, what would go right here to make this to like the new 0 spot? So -4 would go right there, right? If you put -4 there, -4 plus 4 would be 0, and then you'd get an answer of 0 squared. So that's your new center, your new 0. So that moves you to the left 4, right? And so, oops, I should be doing this in red because I want to do 2 different ones. Let's see. So this one's left 4, and so here, and then you do that pattern, 1, 1, 2, 4, and 3, 9 if you have space. All right, so let's say now that you want to go to the right. Well, if you want to move to the right, you'd put x minus, and let's say 3. So when you put a number with the x, it moves you side to side. So inside parentheses is side to side. And so your new 0 spot would be positive 3. And then do your pattern. Okay, so parabolas you can graph pretty perfectly because of the pattern like I'm talking about. All right, so this one's to the right, 3. All right, up or down. If you want to move a parabola up or down, you're going to have to add or subtract a number on the outside. So your x squared is not going to have anything with it, but after that you'd have, like, let's say plus 2. So that means everything, so all of these numbers right here basically get added by 2, right? Because you're doing the squaring and then you're adding 2. So everything moves up. So there's your vertex, and you still go 1, 1. You go 2, 4, and that's all I can do. All right, so then if you want to move down, well, guess what? You do a minus. Let's do like minus 6, how about? So then I can start down here at negative 6. I go 1, 1. I go out 2, up 4. And I can do 3, 9. So 1, 2, 3, 6, 7, 8, 9. So there it is. All right, so then I can do my whole parabola there. Okay, so a reflection over the x-axis is going to be where you put a negative in front. Now we don't do a reflection over the y-axis a lot, right? Because if I drew a parabola and I reflected it this way, back and forth, guess what? It would look exactly the same, all right? So oftentimes the only thing you see with a parabola is a reflection up and down over the x-axis. So that would make my parabola come down. I didn't graph that one great, but you get it. All right, so now we have dilations, all right? So a dilation is going to stretch or shrink your graph. So when you do this, you can say, your teacher might tell you, hey, you have a dilation by a factor of something. And so when you have a number bigger than 1 in front of your x squared, what's going to happen is your answers will get bigger. All right, you're bigger, faster. And so let's see, let's say we put like a 2 in front of my x squared. So imagine what's happening here. All these things are getting multiplied by 2, right? So 0 times 2 is still 0, but this 1, 1 is not 1, 1 anymore. It's now 1 times 2, so it's up here. And 2 is not 4 anymore. It's going to be 2, 8, right? Because it's going to be multiplied by 2. So what happens is your parabola, and then 2 would have been 4, but now it's up at 8. So it's kind of off the picture here. Your parabola gets skinnier. So you can say that that's a dilation by a factor of 2, or you might call it a stretch. Okay. All right, so here you also have a vertical dilation. A vertical dilation, but a shrink. So that would be when you had something like, let's say a 1/2. A number less than 1. So to stretch it, this number has to be bigger than 1. To shrink it, it has to be less than 1. All right, and so 0 is still 0 because half of 0 is 0. But what's half of 1? Because I was going to go to 1, 1, but now I'm going to do half of that. So now it's going to be down here. I was going to go to 2, 4, but now I'm going to go to 2, 2 because my height has been decreased by a factor of a half. If I was doing 3, 9, I would go to 3 and 4.5, right? Like, so because half of 9 is 4.5. So what ends up happening is my graph, my normal graph is looking like this. The new graph is like wider because its height is being reduced. Okay, so half is like right here. 2, 4 would be 2, 2. 3, 9 would be 3 and 4.5. So you can see compared to the original graph up here, that's, a little bit wider. Oh, let's see, half. All right, so it's a little bit like fatter, I guess you could say. Okay, so that's a dilation by a factor of 1/2. All right, so let's put it all together here. So now we're going to have multiple transformations. So you want to decide what each one is. Remember, this one here is going to move you to the right 3, and they're the same as with absolute values. And this one up here is going to move you up 1. So that's the important part. Right 3 and up 1, there's your new vertex, and then you start your pattern, right? And 2, 4, yep, here and here. So there you go. All right, over here, this one's down 4. This is a vertical dilation by a factor of 2, or we could also call it a stretch. So I'll just put stretch for now, but also called dilation by a factor of 2. So down 4 is my important one because that's going to give me my starting place. So remember, I was going to go 1, 1, but now I'm going to go 1, 2 because I have to multiply the 1 by 2. I was going to go out 2 and up 1, 2, 3, 4, but now I'm going to go out 2 and up 8, right? Because I'm multiplying everything by 2. So there's that one, it just matches. All right, so look, it looks skinnier, it's a stretch. Okay, all right, over here, this is kind of the important one. It moves me left 2, so I know to start there. And that's just upside down. That's a reflection over the x-axis. So it goes down here. All right, here we got a lot going on. We have a right 1 and a down 5. All right, and then I have a vertical dilation by a factor of 1/2, or basically a shrink. Everything's half its height. So right 1 down 5 is kind of the important one to get me to start. And instead of going 1, 1, I'm going to go 1 and then a half. Instead of going 2, 4, I'm going to go 2, 2. Everything's half. All right, and then you could do 3 and 4.5, whatever. I'm just going to be lazy and just get it from there. All right, so there we go. All right, so with these right here, we're going to go ahead and figure out the equation. So first I'm going to check and see if there's been a dilation, right? So here's my vertex. I see 1, 1, I see 2, 4. Okay, so no dilation. Okay, so good. So all I have to do is be able to track this movement. It went left 2 and down 6. Okay, so let's write an equation. Left 2 would be x plus 2 squared. That gets me left 2 and down 6. All right, let's check for dilation here. Here, 1, 1. Nope. 2, 4. Okay, no dilation or no stretch or shrink. So it moves to the right 3 and down 1. So right 3 is x plus 3. Oh, nope. Up. X minus 3. And then minus 1. All right, over here, let's check for a dilation. No, 1, 1, 2, 4, no dilation, so good. So y equals, or you could put f of x equals. So the only movement it made was up 5. So now I'm going to have x squared and plus 5, but it did it upside down, so I'll put a minus. All right, so finally, you see how this one looks skinnier, right? So there's been a stretch. There's been a dilation by a factor bigger than 1. So look, here's my normal thing. I was going to go 1, 1, but now it's 1, 3. This has been multiplied by 3. So there's my answer. Y equals, there's a 3 multiplier, and it's been moved to the left by 4. So I'm going to have x plus 4 squared, and it's not up or down, so I'm done. All right, one more thing you have to realize is what you've been doing, or what we've been using here. These are in vertex form, all these things right here. So vertex form, it's easy to say, oh, right 3, down 1. So vertex form is great for literally knowing the vertex. But sometimes you want something in what's called standard form, okay? So if you're in vertex form, it's really easy to go back into standard form because you're basically just going to multiply it out. You're going to take this x minus 3, write it twice because it's squared. And you're going to work it out, like FOIL it, x squared. This is minus 3x and another minus 3x, so that's minus 6x. And this last part is positive 9. So you get x squared minus 6x plus 8. All right, so that's, oops, I should put f of x. All right, so there's standard form, right? So vertex form obviously is best for finding the vertex or for knowing the vertex. because obviously it's called vertex form. Standard form, what standard form is good for? It's good for finding the x-intercepts. All right, because in standard form, what you can do to find the x-intercepts, which we will come to in the next video, but if you take this and factor it and set it equal to 0, remember x-intercepts are also called zeros. So if I factor this, what multiplies to 8 and makes 6? So 4 and 2, right? So x minus 4 and x minus 2. If I set this equal to 0, what makes this 0 is 4, because 4 minus 4 is 0, or 2, because 2 minus 2 is 0. So what that just did for me is, look, it found me the places. This graph crosses the x-intercept at 2 and also at 4. So the standard form is best for finding, oh, I just already read that, finding the x-intercepts. And so the vertex would have been right 3, down 1. So the vertex would have been here because I had that form earlier. So look, there's that perfect graph of my parabola. So standard form is good for solving and finding the solutions or the x-intercepts. Vertex form is best for finding the vertex. So just depends on what you have. And there is a way for going from standard form to vertex form, but we haven't covered that yet. So, all right, that's it. Bye-bye.